Today I'm going to walk you through the high school corn mash and distillation with gas collection. Hi, I'm James Burk. I'm going to walk you through the high school corn mash and distillation lab. And we will start with how to prepare the samples. So we'll set up a water bath. I use a 2-liter beaker. As long as your flask that you're using will fit inside of it. I have students weigh out, mass out 50 grams of corn grind into their flask, and then add, it's not really particular, but 150, 200 milliliters of distilled water to the corn grind, about 200 there. Don't need to boil the water yet, but you can have it warming up. Move it down into the water. If you set the flask onto the hot plate, you'll end up scorching the corn and making a mess, so it gets really hard to clean out. So you want to boil this for about 10 minutes. It will thicken up, especially if we typically let them sit overnight. Class periods aren't long enough to run through the whole thing necessarily in one setup, so it will turn into like an oatmeal consistency overnight. Okay, once the samples is cooled, you can add the students' enzymes that they've decided to use and the yeast. So whatever they've decided. Again, I give them the cost analysis that I went through in the fermenting fuel video. It's stuck in there. So we'll say they're going to add 10 milliliters of amylase. Um, 10 milliliters of glucoamylase. And we'll put 10 milliliters of buffer. In as well. And use this as a stirring rod here. Stir up our corn mash. Go ahead and add the yeast. And I limit them to 5 grams of yeast. You wouldn't necessarily have to, but just to keep them all in the same parameters. Then you can add some water. It doesn't have to be distilled. I usually have enough distilled water in my room to use distilled. But you don't want to fill it all the way to the top. You want to leave about 100 milliliters worth of room at the top. So we fill it up to about the 400 milliliter line. And you can stir a little bit more. So this has everything in it that it's going to need to produce ethanol overnight. It has the yeast, the enzymes to break down the starch, and again, just like fermenting fuel, just on a larger scale, we want to be able to collect the carbon dioxide to be able to estimate how much ethanol we've produced and see who made the most before we distill it. So if you're using a filtration flask, put a rubber stop on here. This is some of the tubing that came with the distillation kit, so you can, whatever tubing you need. A lot of times they want to adjust the temperature. They've decided, and most of the times we run this, somewhere around 38 degrees Celsius, maybe 40 degrees Celsius. So we put this in the warm water bath with a sous vide, and you can, if more than one student group wants to run the same temperature, they can use the same water bath. Get these out of the way now. So for the gas collection, these 1 gallon jugs, I've filled it with 500 milliliters of water and marked each level. So each one of these marks represents a half a liter. I just filled it with water, put some blue food coloring in it to make it more visible, and put the lid on it. That makes it a little easier to flip over into the container. This is the little 3D printed, holds the tubing and keeps it up off the bottom. So you want that in your, you don't want a lot of water in this container. You want to make sure that it will hold the gallon of water in here. If you displace all of the water in this, it's going to end up in here, and if you have it too full, it will end up all over the floor. So what we're going to do is unscrew this a little bit just to make it easier when it's upside down, and then holding that on is going to flip it over into the water and try not to let any air in there. It's a little bit. Get the lid all the way off. Take the lid out now. And this is going to set on top of this little purple ring. And right now it sets down pretty good because there's a lot of water weight on there. As we displace that, it will tend to want to float. So pull it over here a little closer. And there are 4 holes for the tubing to go through. So work that in there. You don't need to put it all the way through. Just it shouldn't slide out. But we want the bubbles to be trapped inside of this. Then we'll let this set overnight. Watch it throughout the day. So we'll tape that down so it doesn't float away as it fills up with carbon dioxide. The carbon dioxide absorbs back into the water relatively fast. You'll be able to watch it on time lapse. So I usually use an old iPad, or if you have an old iPhone 4 or something that you can plug in and run. You can run a time lapse on it and watch and record the most carbon dioxide that ends up in the container. So we're wanting to record the most carbon dioxide that's collected. This is a video that we did in a time lapse with an iPad at one of the workshops. So these are 5 different groups samples, and you can watch them run throughout the day. If they're most of the way full with carbon dioxide, by the time you leave at the end of the day, you can just reset them and record overnight and add the 2 volumes together.
Okay. I'm Brian Nelson, and I teach the middle school version of the Mash and Distillation Lab.
And I'm James Burk, and I teach the high school version.
Today, James and I are going to team up for this particular part of the Day 2 corn mash and distillation, because the procedure for distilling the ethanol out of our corn mash is the same for high school and middle school. And one of the reasons we need to strain and get the solids out of our corn mash is because when we're using our distillation mantle, it can really, sometimes it can burn and get a lot of material in there that's really hard to clean out. In an actual ethanol plant, they would never go through this step. They distill the corn mash and all of the solids, because there is still quite a bit of ethanol in the solids. We just do this to better preserve our lab equipment.
And yeah. Okay, so we're going to pour the solids through some cheesecloth and a strainer here to try to catch as much of the solid. We're after the liquid for the distillation part. So like Brian mentioned, we will lose some of the ethanol, but it does make cleanup a lot better, or a lot faster and easier. So
yeah, let's go ahead and let me swirl this a little bit.
Okay.
Yeah, let's do a little bit of that. I like to do a little bit of a swirl technique. I think that helps it move through the cheesecloth and the strainer a little bit easier. And go ahead.
I just grab it and squeeze it.
Yeah. You want to?
I'm impatient. You want? Go ahead. Whatever.
Go ahead and hold the side here. Oh, you'll go ahead and squeeze it.
Sure.
As we mentioned earlier, there's a lot of ethanol in the solids, so you just kind of got to reach in and squeeze out as much of our liquid as we can.
And you'll get some solids through. It's not a big deal. You don't want enough solids to be sitting on the bottom that it's going to scorch and make cleanup a problem. I've distilled with the solids in, and it doesn't hurt anything, just makes cleanup a mess. Definitely smells some ethanol in there. All right, we'll open that up and add some more. Or do you want to put that in a container?
Yeah, if you'll hold that, I'll go ahead and kind of get rid of some of the solids.
Clean out our filter. Speaking of cleanup.
Yeah, speaking of, this is definitely a messy part of the lab. The kids do love this part, though. They do mention this is one of their favorite parts.
If you're running the nutrient testing along with it, that's a good saving. That corn sample there is really good as well. So now we've completed filtering our sample. We're going to use a funnel and pour it into our distillation flask. So we have our distillation apparatus set up here. In the high school gas collection, we estimated we need to collect about 20 milliliters of distillate. So we're going to turn it on. Is it warming up over there? Water running through our condenser, and we want that coming in from the bottom and out through the top so it stays full. And
when you're putting your apparatus together, all of your joints, you want to use a very small amount of this glass grease to keep your equipment from fusing together. One tip that we want you to, Vaseline is not a good substitute, so you will want to use a high temperature grease that we will send one of these to each teacher so that you have the appropriate high temperature grease to use.
So now we're heating the distillate. Once it gets up to about 79, 80 degrees Celsius, you should start to see some condensation up in here. That's going to have some water vapor in it still, but mostly ethanol because the boiling point is lower. So that will eventually start to condense in here and drip across. So we're trying to leave the water in this container and get all the ethanol into this container.
James, would you like to talk to him about where you place the thermometer and why you place the thermometer where you put it?
This thermometer seals up here so you can adjust it, but you want it right where the junction is right here so you know what the vapor temperature is right here. It doesn't matter so much what it is down here or anywhere else. That tells us if it's 80 degrees Celsius here, that's the boiling point for ethanol, so that's what's going to be condensing at that point. If you overshoot that, you'll be getting a lot more water driving across. In the other glassware, you had to heat it quite a bit higher, get into the 90-degree range to push it over. So we've let this run for a few minutes, and you can start seeing some droplets condensing on the flask here. That will reflux or drip back down. Eventually, these droplets will move up as the distillation progresses, gets warmer. You want to keep an eye on your thermometer because it's going to start going up relatively fast once it. About 10 minutes in here and we're starting to see quite a bit of reflux up in this area. Our temperature has gone up to about 45 degrees Celsius. Once the temperature starts going up in the thermometer, it goes up relatively fast. That means you're getting some pretty good boiling going on down in the distillation flask and the vapors condensing up in here. So you'll start to see some droplets form in here. Got a few droplets forming right here, and we'll start seeing it dripping over relatively quickly. Okay, we're starting to get a lot of vapor condensing in the condenser, which is what we want. So we're going to turn the mantle down a little bit so we don't heat too much water. And we're starting to get some distillate dripping into our graduated cylinder. Again, based on our calculations, we don't want to go much over 20 milliliters. Okay, so we're going to pour some of our distillate into a watch glass, and if it will sustain a flame, it's in the 35 to 40% ethanol range at least. Sometimes you have to heat it a little bit to get it to start evaporating. And it's lit, I believe. Okay. Yeah, it's burning. In a good sustained flame, probably about 5-6 inches tall. If you attend a Seed to Stem workshop, the glassware, the mantle, and ring stands are provided by Renew Kansas and Kansas Corn.
And we'd love to see you guys work with this equipment, making ethanol in your classroom with your students. If you ever run into any issues with this, because as you can see, it's not a hard lab, but there is some technical aspects of it. So if you run into any issues whatsoever, you're welcome to contact myself or James. You can get a hold of this through Kansas Corn STEM. And we'll be available for any questions you might have.